In this video, we are going to be finding the surface area and volume of a regular size Hershey's chocolate bar, and then later, using that information that we found, we're going to be finding surface area and volume of a big 5-pound Hershey's bar. So to begin, we just have the measurements of a regular size Hershey's bar. The bar is not just a regular rectangular prism, which makes it a little bit harder to find surface area and volume. Each side is actually a trapezoid. So here I just have labeled the measurements of the bases of each side, which, like I said, is a trapezoid. So this just top base here is be 13.2, and then the bottom base is 13.8, and then same with this side, 5.5 and 4.9. And then right here, these measurements is just the difference between the bottom base, this outside edge, and then the inner rim. So the first thing we're going to do is find the volume of this regular size Hershey's bar. Like I said, it's not just a rectangular prism, so what I did to find the volume was I broke it up into triangular prisms, one big rectangular prism, and then a pyramid. So in this drawing here, these would represent the sides of the Hershey's bar, which are just right triangular prisms. And then you can see there's a little corner piece left out there, which actually represents 1/4 of a square pyramid. And then the part that would be in between these, which would be this piece, this part right here, would be the big rectangular prism. So first what I found was the area, or the volume of these triangular prisms. So I just used that, used the formula for the volume of a prism, which is the area of the base times the height. So I found the area of this right triangle, multiplied that by the height, and got 0.792 centimeters cubed as my answer for the area of this triangular prism. Did the same thing for this one and ended up with 0.294 centimeters cubed. So again, this is just the long side and the short side. And then, like I said, there's the big rectangular prism in the middle, which to find the area or the volume of that, you do length times width times height. And I ended up with 25.872 centimeters cubed for that. And then, like I said, the piece right here, the empty piece, is 1/4 of a square pyramid. So putting that piece from each of the corners of the bar together, you'd get one full pyramid, since there are 4 and each is 1/4. And the volume of a pyramid you can find by using a formula. Volume equals 1/3 base times height, the area of the base times the height. So I found that, which I found to be 0.048 centimeters cubed. And then to find the total volume of the Hershey's bar, I just added all the volumes that I had previously found together, which was the area of the triangular prisms for the long sides, the triangular prisms for the short sides, the big rectangular prism, and then the pyramid. And my total volume was 28.092 centimeters cubed. So next up is to find the surface area of the regular Hershey's chocolate bar, and I broke this up into 6 different faces. The top face of the bar is just a rectangle, and then the bottom face is also a rectangle, but it's a little bit bigger. And then each side, like I have said before, is a trapezoid. So I started out by finding the area of the longest trapezoid, which is the longest side, and the opposite sides are congruent, so you only have to find it once, and then you can multiply it by 2. So the area of a trapezoid is base 1 plus base 2 over 2 times the height. So I just plugged in my values and found the area for the longest side to be 6.75 centimeters squared. Did the same thing for the shorter side right here, and found my answer to be 2.6 centimeters squared. So then what we were left with was the top and bottom rectangles, which you just use the formula for area of a rectangle, which is length times width. And I found the top rectangle to be 64.68 centimeters squared. And then the bottom one was 75.9 centimeters squared. And then again, like I did with the volume, just added all the surface areas that I had gotten together, which was the longest side surface area times 2 because there are 2 of them. Shortest side, again, times 2 because there are 2 of them. And the top rectangle, the bottom rectangle, my total surface area was 159.28 centimeters squared. So now, like I said, we're going to be finding the surface area and volume of a big Hershey's chocolate bar, which is what we'd consider a similar object to the regular size Hershey's bar. And the formulas, we are given some formulas which give us a better shortcut than having to go through the same process as we just did for the regular Hershey's bar. So our formulas for finding volume and surface area of a similar object are surface area 2 equals surface area 1 times k squared, where k is the scale factor. And the reason we would square k is because surface area is 2 dimensions, so it would be k times k, which would be k squared. And then for volume of similar objects, we have volume 2 equals volume 1 times k squared, where k again is the scale factor. And volume is 3 dimensions, so we have k times k times k, which is k cubed. So what is scale factor, or k? A scale factor is a value that represents the ratio of a characteristic, say a side length, of one object to another similar object. So for example, the scale factor between these 2 rectangles would be 2, because in order to get from one to the other, you have to multiply the side length by 2. So your check to make sure your scale factor is correct would be 4 times 2 equals 8, and 2 times 2 equals 4. Alright, now it is time to find the volume and surface area of the Mega Hershey's bar. So just an outline of the process. We know what we have, which is the total surface area of the regular size bar and the total volume of the regular size bar. What we want to find is the surface area and volume of the Mega bar. So what we need to find is the scale factor in order to be able to use those formulas that we just went over. So to find the scale factor, what you do is you just, like I said, set up a ratio between the characteristics of 2 similar objects. So I just have the side length of the bottom rectangle on both the regular size Hershey's bar and the mega sized Hershey's bar. So the value for the regular bar is 13.8 centimeters and the value for the mega bar is 45.72 centimeters. So I just set up a proportion, or not a proportion, just a ratio. So 13.8 over 45.72, and we get our scale factor to be 0.302. So now we can go in and use those formulas. So now we just plugged in our values. So we plugged in the total surface area for the regular bar and the scale factor into our formula and ended up with the surface area for the mega bar being 1,748.298 centimeters squared. Did the same thing for volume, plugged in our total volume for the regular bar and our found scale factor, and ended up with the volume for the mega-sized Hershey's bar being 1,021.560 centimeters cubed.